Good day and welcome to CppChat. Before we start the chat, I need to share this disclaimer. We are not doctors and cannot give medical advice. Please consult your physician before starting any program of diet and exercise. But we do have two new guests today. First of all, I want to introduce Deane. Ben is joining us for the first time. Ben, you want to tell us a little about what you're working on or what you're interested in?
Sure. Hi. Thanks, John. I'm a game industry programmer. I've been in the games industry 21 years this year, and I currently work at Blizzard in Southern California. In the last couple of years, I've become really interested in C++. I gave a talk in Aspen at C++ Now in 2015 and repeated that talk in Bellevue. And I'm giving a couple of talks at CppCon this year based around my interest of in my spare time, I'm a bit of a functional programming enthusiast, as several members of the C++ community are. And I like to try and sort of bring those things to bear on the C++ that we all know and love. So keeping the performance, but using the functional programming techniques to improve APIs and make things clearer and things like that, and taking some learnings from things like Haskell and a bit of type theory to make C++ better.
Making it easier to reason about code.
Exactly. Easier to do the right thing, harder to do the wrong thing, and easier to reason about.
Right. Excellent. Excellent. Our other guest today is Jonathan Mueller. Jonathan uses the nickname foonathan. Foonathan? I don't know how to pronounce it.
It's my German. So the German pronunciation of my name is Jonathan, and when I try to come up with a name, I just picked foo from bar and slapped it in front of the Nathan, and so it's foonathan in German, but I'm totally open to calling it.
Okay, I'll buy that. All right. Well, tell us what you're interested in, what you're working on.
Yeah, so I'm a computer science student, and in my spare time I work on C++ projects on GitHub. For example, I work on Memory, which is a C++ allocator library. And I'm currently working on standardease, which is a C++ documentation tool like Doxygen. I also started blogging for over a year, I know, almost a year now, I think. Yeah.
So, you mentioned the standardease. I wanted to. I'd forgotten that you'd worked on that, but when I first heard you mention that a while back, I guess on the CppCast interview. You mentioned that, and I was wondering if you've looked at DoxyPress and what Barbara and Ansel are doing.
Yeah, I've looked at DoxyPress, but at the time where I looked at that, it was just they haven't changed the part of Doxygen that I was fed up with, namely the parsing and the documentation generation, which isn't quite adapted to modern C++. For example, they still use this class-based separation of documentation. And then you manually, it is kind of awkward to specify free functions which are related to a class. And for example, I group everything by file instead of by class, because the stuff in a file usually should be documented together.
So my temptation would be to group things by namespace, because that's how ADL is going to work, right? And so if you have free functions that are in the same namespace as a class, then those free functions are effectively part of that class's. If it's a free function that takes an object of that class as a parameter, then effectively that free function is part of that class's API, right?
Yeah, but it's just then I put everything in a header file into one documentation file, and then maybe the files would just get way too big if you have everything.
It depends on how granular your namespaces are, right?
Yeah.
I mean, if you just have one namespace for your project, it doesn't bother you very much, which is probably not uncommon. I suspect a lot of people basically put their project in a namespace, and that's how that makes perfect sense. Yeah. So, okay. So you should also mention your blog, because I think we're going to talk about that a little bit.
Yeah, so I blog at foonathan.github.io. It mainly started because I wanted to share some of the concepts I use in my classes, and they didn't fit into a single tweet. So I have to open a blog and then talked about some of the implementation of more memory stuff and gave tutorial about the allocator concept, but now I'm just blogging about everything which I think about when programming.
So you mentioned you're a student. Are you? What year are you in?
I'm starting next week.
So you're a freshman, a college freshman.
I don't know what college is exactly. I'm in the American system. I'm going to university and making my bachelor. I don't know what the American equivalent is.
Right.
We would say the same thing, university and bachelor, but we say college as well as university.
Okay.
Generally speaking,
synonymous.
Yeah, generally speaking, a university is a college large enough to have colleges within it. So a university will usually have a college of arts and sciences, there's a college of engineering, perhaps a college of health sciences. You know.
Okay, so basically a faculty.
Yeah. Okay. So I was going to ask you about your instructors and the classes you're taking, but you aren't quite ready to talk about those yet, are you?
Yes.
Are you taking any programming classes in your first semester?
I'm making a Bachelor of Computer Science. So at Aachen, which is a very theoretical classes, so I mainly have math and a little bit of programming in my first year.
Okay, all right. Well, we'll be anxious to hear your reports as you go through the system and have them try to beat any love of programming out of you.
Yeah.
Yes, computer science doesn't, in my experience, doesn't teach you programming. It teaches you computer science.
Yeah.
Well, that's one of the things, and I have a friend who I happen to mention software engineering in front of, and his reaction was amazing. He said, "Software engineering, that's code for people aren't smart enough for computer science," and I'm just shocked because, from my point of view, I mean, I don't want to say negative things about computer science. That's not my point. But what I'm saying is that the big need we have is for software engineers. Right? We need someone who can reliably make release after release of multi-million line code bases, right? Whether it's a complicated website or an application or something like that. And I'm not saying that we don't also need computer scientists, but we have them. We're turning out class after class after class of computer scientists, and then what do? They go get software engineering jobs. I think we would be better off if we trained people to be software engineers instead of have them learn that on the job the hard way. And again, I'm not trying to denigrate software engineering, but there's a different discipline here. You know, the difference between understanding how to write an algorithm or write a compiler or something like that. That's a different set of skills than figuring out how to write an application that will scale and be maintainable, millions of lines of code over a decade. That's
well, I was with you right up to the point where you said how to write an application that will scale. Because I think computer science is a very important skill for building the Googles and the Facebooks, and frankly the compilers that we use. So infrastructurally, computer science is incredibly important in my view. But I think you're right in terms of, software engineering is definitely another very important pillar.
Yes. When I first started in college, and this was way back when, I think computers hadn't been invented yet. But I started out as a chemical engineering student, and so I'm very, very understanding the difference between chemistry and chemical engineering. And it's not because I don't think chemistry is important. Clearly, you don't have chemical engineering without chemistry, right? I mean, you have to have them. But if you want research done on chemical processes, you look at chemists to do that. But if you want to build a factory, if you want to build a refinery, if you want to scale that process to handle several million gallons or whatever it is you're trying to do, you look at chemical engineers to make that happen. And I think we have the same kind of thing in software. It's not that we don't need computer scientists. It's that we need lots and lots of software engineers, and we aren't. And all the software engineers we have, I should say all, there are some colleges producing software engineering programs, but for the most part, the software engineers we have are people who got a degree in computer science and learned how to do software engineering on the job. and that means they learned it ad hoc. There's not as much agreement in the industry as there should be. There's not as much knowledge. We learned all the hard way. Anyway, my little digression on my little soapbox about software engineering. We should talk about your latest blog post. You want to tell us what you wrote before I tell you why you're all wrong about it?
Okay. So, a month ago, I wrote this blog post about move safety that was discussed in an earlier episode here. And while I was writing this, I was thinking about something else that I couldn't fit into the original blog post, namely that if you have a class that owns a resource, before in C++98, this class you have a constructor that allocates the resource and then a destructor that frees it, and then copy construction is disabled because you can't copy the resource. And that's if you design the constructor in a way that if the resource couldn't be created, it was an exception, then there is no resource holder object ever. So every object you can create holds a valid resource. So you can always call all member functions on the object because every object holds the resource. There's no way to create an object that doesn't hold a resource. And if you introduce move semantics,
well, hang on, before you do that, I want to make a point. I don't want to stop you. I just want to interrupt you for a minute.
Okay.
That's what RAII is all about, right?
Yes.
That's what resource acquisition is initialization. What that actually means is if I have the object, it means I was successful at acquiring the resource.
Yes.
And if for some reason I couldn't get the resource, I threw an exception, and the object doesn't exist. So it converts resources into objects, right?
Yes.
If I have the object, I have the resource. If I don't have the object, okay. Now, that's classic RAII coming from C++98. That's what we've all been using. Now, in C++11, we introduced move semantics, and you're wanting to talk about the implications of that on resource-owning objects.
Yes.
Okay.
Because move semantics usually steal the resource from the original object, so the original object doesn't have a resource anymore. So if you use it, and it doesn't matter why you use it, it may be a mistake or something like that, you have an invalid object, and suddenly you have to specify for all your member functions that you must not call it on a move from object, so suddenly they all have preconditions, where before they didn't have any preconditions because every object has a resource. And yeah.
Okay, all right. I'm happy to jump in. Okay.
Okay.
So in your blog, you said that you now have this new undefined behavior. Yeah. And I agree, it is a new undefined behavior, but it is undefined behavior. You do not need to specify it. Just like if I'm writing a function and I say, oh, I take a pointer to a socket, which is a class that you talk about. If you take a pointer to a socket, I don't have to say, by the way, this pointer can't be to a deleted socket. Yeah. Because that would be undefined behavior. And what I'm going to argue now is I also shouldn't have to say, by the way, it can't be a pointer to a moved from socket, because that's also undefined behavior. And the reason that's undefined behavior is because of what we discussed, and the reason I objected to your first blog post about this is that a moved from object is a partially formed object, and there are only two valid things you can do. You can either destroy it or you can assign to it. You cannot pass it to some other function that's expecting a pointer or a reference to this object. It is moved from. All you can do is assign to it and destroy it. And so I'm saying that we haven't introduced a new, we've introduced a new kind of undefined behavior, but we haven't introduced anything new that existing code has to deal with, because passing a moved from object to a function is undefined behavior. It just is. And so it needs to be treated that way, because in your original blog post you said, well, we have to decide what we're going to do with moved from objects and what state they have. Yeah. And what I said was, no, we don't. We want to be really clear. This is what the state is. They can't be used. And go ahead, Ben. I didn't mean to.
Sorry. Yeah. I was going to say, I'm with you, John, in that I think moved from objects should either be destroyed or assigned to. But maybe part of the problem is that right now that is a convention, and certainly a convention that has some following, but it's not mandated anywhere. And there are plenty of cases, I'm sure, out there where people are writing objects where there are no preconditions on some other functions. In other words, you could call a function on the object even if it was moved from. So I think there's a camp that likes no preconditions on their methods.
And it's also, there are some cases where it makes sense to use a moved from object, which I mentioned in the blog post about move safety, for example, unique pointer. It is defined. The moved from state is exactly defined. It is a state where the pointer is null, so it doesn't have anything, and you can just reuse it as a regular object.
Well, but that's an interesting situation because that is a move-only object specifically designed. I mean, that's why we have that object because we have move semantics so that it can be happen. But I think as far as the convention, I understand what you're saying, and I certainly understand that someone for their particular object can say, well, I've looked at my object and I've thought about what it means to be moved from, and so I'm going to document this state. And I think that's a disservice to callers because I think we need to work very strongly to communicate to people that using these objects in any other way is semantically nonsense. I disagree with what you said, Jonathan, in one sense. And you said, well, there are situations where you want to use this moved from object. And, a unique pointer is interesting because it isn't really an object, it's a pointer. And all you've really said is, oh, I moved away the object. And that's just the semantics of how to say, I've emptied this pointer by moving him somewhere else. So that's kind of a weird situation. And I do understand that it's different from most things. But in the general case, a move from object, if you're thinking, oh, I'm going to move from it, and then I'm going to make some interesting use of it, I think you're confused. That is not an appropriate, there's no such use case. And if we go around telling people, oh, well, there are certain classes that you can do that, and you should write code like that, I think we're doing them a disservice. You should design your code so that if you have a move from object, you either are just going to destroy it, or you could assign some new thing to it. And so if you have an algorithm where you're sorting something or you're moving something around, it makes perfect sense. I moved from this, now I'm going to move something else to it in its place. Those things all make sense. Swapping things around, that makes sense. But a situation where you say, well, I moved from it, but now I'm going to use it for something, I just think you haven't thought that through. And I just think that should be a really strong message that we give people. It's like, I don't know a good example of another really stupid thing that sometimes people do. Maybe like using globals or something. It's just, if you're doing that, you haven't thought the problem through. Except there are some times when you want to use globals. I just don't think there are times when you want to reuse a move from object. And I think if you're doing that, you haven't thought it through properly.
I think there is somewhat of a semantic difficulty here, or an operational difficulty for classes that take resources in their constructors. RAII is fine, but there's a significant, there's a significant amount of code out there that provides default constructors that don't acquire resources, and then the class has a later method to acquire the resource because it's expensive, or you want to control when it's acquired more tightly, or you want to, just decouple those things. So I think, was it Jonathan, you made the point, or maybe I read it on the Reddit, that in that sense, there's not really a way to distinguish between a default constructed object and a move from object. Neither one of them has the resource. You still have to check. I mean, with the proviso that using a move from object is undefined anyway, but semantically it's not on a good footing, I guess.
The point I also was trying to make, John, you said that unique pointer isn't an object. It is a pointer to an object. And
semantically.
And semantically, I get the feeling that whenever you add move semantics to an object, that was the point I was trying to make in the blog post, it also behaves like a pointer, like an optional type. You either have a resource or you don't have a resource. Just because the compiler isn't preventing you from reusing a move from object, it is a truly destructive move. So, in a way, it also transforms it into an optional resource instead of a resource.
I think in practice that's true, and I think that's the wrong way to think about it. And if you think about it, it's going to lead you down the wrong way. If you want an optional object, use an optional type. If you want a unique pointer, then use a unique pointer. And then you don't have any of these issues. But I think that having an object and saying, oh, I'm going to move from it and then use it for something it means you haven't thought this thing through. Now, yeah. I would say this, referring to what Ben was talking about earlier, that it does make sense to have resource handling objects that have a default constructed state without the resource. But I will argue that makes a more complicated object. It makes it more complicated for the user, and it makes it more complicated for the author of the object, because now you have to realize both the user and the object author has to say, okay, now there are, I have loosened my my invariance on this object. Now having a resource is no longer an invariant. And so I have to think about that all the way through the design of my object. And I think that in most cases that's going to be problematic. Now that doesn't mean that there won't be, and Ben gave the perfect example, if you have a very expensive to acquire resource, you may have an object where you say, no, I really need to control when the resource is acquired, and so I'm going to pay the price through the entire lifetime and API of the object, that I'm going to constantly be aware of the fact that, well, it may not yet have a resource. That's a non-trivial kind of thing. So I wouldn't want to do that with something like, I don't know what the right example is, but if you had a string class, for example, I would say, I don't want to have a situation where we say, oh, well, I tried to construct this string class by giving it a string, and it failed to acquire it, but that's okay. I'll just have to call some member function of the string and say, are you a valid object or something like that, or do you have the resource? That complicates your API, it complicates your reasoning. It's better to just throw an exception.
And John, what you're saying about the default constructor, that it makes it non-trivial, you have to design the interface, it makes it more complicated, that's exactly what I think about the move constructor. Because it also allows the state without resource, like the default constructor. It also complicates the interface, because then you have...
No,
unless...
That's my point, is you need to treat the moved from object as no longer an object. It's logically similar to a deleted object. I don't worry about, well, if I delete it, then what happens if somebody calls or uses it? No, that's undefined behavior.
But it isn't enforced, it's just a convention, and that's my entire point.
Well, but you need to think of it, you need to say, when you create your objects, you need to say, well, by the way, if you use this object when it's moved from, that's undefined behavior.
Yeah.
You need to say that, and we need to follow that, and it's not a burden to the caller. And I think that's the point I was trying to make earlier with the earlier blog post, is that I think people writing libraries are trying to hold themselves to a high standard. I love that. I want high-quality libraries. I want library authors to think of their clients first. That's great. But what I'm saying is, when you think, okay, I'm going to then document my moved from state, and I'm going to say what you can use in the moved from state, I think you're doing a disservice to the client. I think you're better off. Undefined behavior is a wonderful thing. It allows us to say, I don't have to support scenarios which, if I had to support them, would cost you, the client. So I'm not going to support them. I'm just going to say, don't do that. And as long as you don't do that, everybody's happy. I can make my library safe and performant, and you can use a safe, performant library, but we both agree you're not going to do that, whatever the undefined behavior is. And that's my point about this. And I think what's seductive about it is that for an awful lot of objects, the moved from state is simple, cheap, easy. I think this is why the standard committee made the mistake, and I think I said this before, I think the standard committee made a mistake in saying that standard objects, you can call any member function on a standard object that's been moved from that doesn't have a precondition. In other words, you're not restricted to just destroying it and assigning it. And I think the standard committee thought they were doing a good thing. But I think they're doing a disservice to clients, and I think that's setting a bad precedent. I think it's a mistake.
I tend to agree. Another good example I was just thinking of decoupling RAI from construction is if you work in a code base that doesn't use exceptions. So whether you put the resource acquisition in the constructor or in another function, the fact that you can't throw an exception from the constructor means that you're still checking everywhere.
In a way, I agree with you, John, that you shouldn't reuse a moved from object, but I think it would be nice if this would be enforced, if move semantics was defined by the language, that after an object is moved from, you cannot actually reuse it, instead of this fuzzy thing we have right now.
Well, I'm not sure what you mean by enforced by the language.
Yeah, if we have...
The compiler is not going to be able to detect this situation, and we wouldn't want to try to do that. But the language, the standard could in fact say that it is invalid to use a move from object in any way. Of course, yes. That would mean that unique pointer, unless they call that out as an exception, which I would actually be okay with. I mean, unique pointer is a special device for that reason, but that would mean that you couldn't write your own version of unique pointer that was similar in concept but implemented a different way for you, right? Because then you'd want that exception to be for that too. So I'm not sure the standard has to say it. I think the job of communicating this falls to people like you who write blogs and me who teach people, and Ben maybe when he writes a library. We need to say, look, this is the proper way to write code that can understand the move from object. The whole problem only happens if your code actually uses an STD move, right? It never is a problem in, what I would call natural code.
Right.
Natural R values, naturally occurring R values are not reusable. They just can't be. So it only happens when someone decides, oh, I want to call STD move on something. And what I'm saying is you've accepted that now the burden is you need to track that object and never do anything else with it other than allow it to be destroyed, or, yeah, you could actually reassign.
So one of the interesting things about this blog post for me was that I was thinking about regular types and a little bit about a talk I'm going to give at CppCon about using a little bit of type theory to inform how to make better interfaces and structs and things. And it comes down to, this touches a bit on, as C++ programmers, we're used to thinking about performance and about the machine, and the heritage of C++ is rooted in C, and so we tend to have a very representational viewpoint of what a type is. If you ask someone what is a type, as likely as not they're going to say, well, it's a machine word, or a collection of machine words. And what we really are saying with this move construction and talk about, possible default construction and or deleted objects. To be a type, you need to have that semantic link between the representation and the mathematical notion of what your type is. The in some sense type theoretic or mathematical idea. So when you write new object, what that does is allocates memory and then calls the constructor. But in between those stages, what you have is not a type yet, and it's the same, in deletion, and it's the same with moved from. Once you've moved from, you do not have a member of that type anymore. Is I think what we're saying. And so the only way to restore that semantic link is either to assign. Well, the only way to restore it is to assign it, or you can destroy it and release the memory.
I think that's another way of saying what I've been trying to say. I think that's as you say a type representational way of thinking about it. I want to say somebody, it's MTT in the chat room has, I guess, given me a challenge. He said, imagine I'm examining some code. I have the code that I create a socket S, and then I pass S in a macro, and then I want to use S. It says, before C++11, would you have to audit macro to see if the invariant had been torn down? I think, I guess, the macro could do bizarre and interesting things, and the macro could actually take the address of S and call delete on it, which would be the equivalent of what we're saying a moved from is. It's essentially deleted, although it's not completely deleted because you can assign to it. I mean, but I guess what I'm trying to say is I want to convince people that moved from is very much like deleted. It's not exactly deleted because it's a Phoenix deleted, right? You can assign something else back to it. But you should treat it like it's deleted, and that's what you've said. Move from this. You've said this object. Move from it. I'm not going to. I promise, implicitly, what you're saying. I promise I won't use this guy again. And the only back door to that is, well, yeah, you could assign to it because it's reassignable. That's stipulation. and anything else you're doing, I think you're. I just let me put it this way: you shouldn't be doing that in generic code. Yes, it's possible that you know because the standard told you, oh, you can move from a vector and then reuse it, and okay, fine. I just think that's you wouldn't want to do that in generic code. You can't make that assumption blanketly. If somebody promises you, here's this particular object, it behaves this way in the move from state, I guess what I would say is, don't tell me about the move from state. I will never use the move from state for anything else because I don't see any advantage to it. Anything I design, I can be as efficient as I need to be without worrying about move from states.
John, you previously said that you would make unique pointer an exception because it doesn't behave like resource, but as a pointer to resource. So you would make it an exception from this rule. You said that before.
Well, yeah, because yeah, essentially, the unique pointer is the equivalent. I mean, it's semantically a pointer, not an object in that sense. Obviously, yeah.
So it would make sense to make the exception for all classes that behave like pointer to resources instead of resources like the optional resources that have the full interface and that you maybe can also call the has a resource function, query function on a moved from object instead of just reassigning it. So maybe that we have two kinds of move. One move which is truly destructive for classes that don't behave like pointer to resources but just like resources, though they should always have a resource for every function, and then classes that behave like pointer to resources, which you can query and do other stuff.
Again, my point is, for what reason? There's no reason to do that. If what you want is an optional, make it an optional. I mean, there's no reason to have an object that you're going to pass it around, and it's a container. You know, it's effectively a pointer to something, but you don't want to use unique pointer. Well, why not use unique pointer if that's what you're really saying? Not really this object, it's a pointer to this object, and it might be null, and you can check to see if it's null.
Yes, but I mean, unique pointer is already there, and maybe you can't use it because you're in a freestanding implementation or something like that, so it would make sense to write your own class that behaves like a pointer to an object. You see my point?
No, I'm not sure. Say that again. I'm sorry. I was distracted because MTT is sending me more stuff.
Oh, okay.
He's trying to he's trying to debate with me as well. I don't know what's going on.
So we have these two kinds of resource classes. One that behaves like pointers, like mainly unique pointer, and one that behaves like the actual resources. And for the classes that behave like pointers, there are maybe for some reason other classes except then unique pointer. So it makes sense to also add an exception to them. So that it makes sense to widen the unique pointer category to all classes that behave like pointer to resources, and that in a move that they have a default constructor, a query function, and it's safe to use moved from objects for some functions on them.
Well, again, I would say, I mean, I don't know. I mean, you're making it sound like there's a whole class of things that behave like unique pointer. Well, there are. They're called unique pointer. I mean,
yes.
I don't know what else you need to do what unique pointer does. I mean, what are you thinking? You also need a unique pointer that's ref counted or something? I mean, it has a ref count that goes to 1.
The other thing that this post made me think about, just sort of changing direction slightly, thinking about regular types, it struck me that default construction is actually a fairly odd thing, in that, you know, it doesn't really apply to everything. It doesn't apply to integers. You know, they're just uninitialized. They don't, apart from in generic code, in certain circumstances, you declare an integer. It's not default constructed. It's undefined behavior to read from it before it's assigned, or copy constructed, or whatever. So, and it's also quite odd in terms of our ability to reason about the code is in some sense impacted by this constraint on regular types that they all have effectively nullary constructors. I'm giving a talk at Bellevue in September a little bit about this, And I found when I practiced this talk, people would kind of get stuck on this point. I tried to marry the idea of regular types with kind of being able to reason about some constructs I give in the talk. And so to give people a footing to reason about it, I said you can assume that all the types I use here are regular, and let's see where that takes us. But then I realized that regular type has a default constructor, so that definitely hinders the ability to reason about function signatures. If you can assume that, anyone at any time can conjure one of these things out of thin air because they don't need any information to do so, it's got a default constructor. That is strange in my view.
I see what you mean. We have a concept called semi-regular type. A semi-regular type is a regular type that doesn't have a less than operator, right? Because that is there are perfectly valid types, like for example complex, right? You can't do a less than on complex. You may want to do lexicographical comparisons because you may want to use a complex as a key into a container or something like that. But it doesn't make sense to say less than. And so if you want to sort complex numbers, you have to figure out what you can do lexicographical sorting, but that's not the same thing as less than. And the reason I say this is because you could imagine some other semi-regular type which doesn't support default construction because it does make some sense to say that there are types for which nullary constructors make no sense. Maybe
I think for value types, perhaps.
Well, value types often have this kind of natural null. For strings, it's an empty string. For most things, it's 0.
Sometimes.
But if you had a color, what is the default natural?
Right.
It could be black, it could be white, I suppose. But
it's arbitrary either way.
But date is an interesting one because date, the obvious one is now, but that requires a little bit of processing. I'm not sure I would want my default constructor to be now, given that that's not free.
And that's also not the same for every object, obviously, and I think this also can lead to issues if you have default constructors that vary on, the time of day for the result.
I suppose, yeah. I mean, it does kind of make sense that you would say, I want to default construct I want to default construct time A and default construct time B, and then I want to say A equal equality of B, and that turns out to be false because.
Yes.
But that's not impossible. I mean, you wouldn't necessarily have to do the same. But as I said, yeah, it's an issue. What is if you just have time? You could just say, oh well, midnight. That's the default, or noon, I guess, or midnight probably makes more sense. I don't know. But it does make sense that there are some things that just don't naturally have a default value.
Right.
And in those situations, usually you don't want to do any. I mean, the functions. The reason we talk about regular types is generally because that's what the standard library wants for contained objects. But there aren't very many container member functions that actually use that fact.
Right.
So if you call resize on vector, that's one. If you use an array indexing on a map, that's another one. It uses the default constructor if the object, if the key is not found, it creates the key and rates it. Right. But I think you can, for most of the containers, and I may be stretching my knowledge here, I may not be correct, but I think for most of the containers, you can do most of the things you want to do with an object without a default constructor by just not using any of the particular method. It's a template. If you don't call that function, it doesn't get instantiated, and the fact that it wouldn't compile if it did get instantiated, and turns out to not be a problem.
Yeah, and for those functions you mentioned, resize. So resize to a larger size, I'm having trouble seeing where you would want to do that rather than reserve. Resize to a smaller size, sure, but that doesn't require default construction.
Well, it does because the compiler is going to generate the code. Well, I mean, it would never be executed.
Oh, I mean, it wouldn't execute.
It wouldn't compile. Yeah.
So it's an artifact of the way we build it that requires default construction, I think, is what we're saying.
Yeah. Yeah.
And the map lookup, or the map, it's not lookup, is it? It's the square bracket operator
It's
on
array index. Yeah.
Right. Is problematic in a few ways. Firstly, the const issue is is a problem that I'm sure everyone who's used the map has run into. And it doesn't really work. As my talk in Bellevue will show, it doesn't really, you can't reason about it very well. It doesn't really work from a type theoretic point of view, because what we should be returning is an optional, and now we have optional, but I'm not holding my breath for it to change, of course.
No, I wouldn't do that. Although, you know, if concepts gets voted in, we're going to have a new standard library, and that's the kind of thing that I think we should. This is one of the things where I think people who are clamoring to get concepts in right away, I'm kind of pushing back and saying, if we're going to have to rewrite the library, let's think about these kinds of things. Does it make sense to change the return type of the index operator, at least in the I mean, these are the kinds of things that I think we would want to think about. If we're going to rewrite the library, don't just say, oh, it's exactly like the old library, but now it does concepts. It's like, I think that's a missed opportunity. But I think the thing is, we need to think of what is the name of a otherwise regular type that isn't default constructible.
Right.
A non-default regular type? We have to have a term for it, right? Can't call a semi-irregular type, because that one's taken.
A sub-regular type or something? I don't know.
Jeff is saying, can anyone give a concrete example of a type which is difficult to use that has been moved from? I think in most of the standard objects, it can be, and that's kind of why I think most types, if you could be designed to be done this way. And I think that's probably the seductive reason that people are doing it, because it's so trivial. And say, oh, well, if you move from the vector, it's now just an empty vector.
Yeah, and that's the reason you also need this other kind of concept, because all the types in the standard library don't model resource, they model resource or zero resources or multiple resources in case of standard vector like that. And for those types, it makes sense to reuse an object after default construction, because you can safely query how many objects are there. Are there any object or resources actually owned by the object? Unlike the objects that are just mere wrapper around handles without invalid handles, that actually model a resource, there you must not reuse a moved from object, because it would be totally bad for the violate every environment.
Right. So I think the example I would think of first, Jeff, is a stream, because you can move from a stream. So let's say you have this file stream, and you move from it. So now somebody else can write to or read from this file stream, but the original file stream doesn't make any sense. It no longer points at a particular file, and so it's and that's, I think, the more interesting kind of situation. Although in most of the examples that I can think of like this, Jonathan used the socket example in his
just because
I think that's very good. But one of the things he also points out, he says, well, sockets can go bad for other reasons, and so you might have to check them. And it's true also that streams can go bad, and that's how the standard can get around it. In other words, they say that anything that doesn't have prerequisites can still work. Well, all stream operations essentially have the prerequisite that the stream is that the bad bit's not set, right? And so when they move from it, they set the bad bit, and so that works. And in general, I would say most of the examples I can think of probably have something like that. But I don't want to preclude this for what I view as, if you've written software where you're moving from something and then trying to reuse it, that you haven't thought the problem through. And that's what bothers me.
Right.
It's not that it couldn't be done. In fact, I think the standard library, the standards committee has decided the standard library can be done, and most of the examples we see can be done. And my argument is not that it can't be done. My argument is that it shouldn't be done, because you haven't thought things through. If this is what I think we need to get to when we teach programming. It's not just, how do I make the computer do stuff? It's how do I do it in the clean and proper way so that we can reason about it going forward. And
one thing, your stream example make me realize about something. When you say you can only use the moveGem object to destroy it or assign it, you also have to specify what's assign function, because I think on a moveGem stream you can call the redirect buffer function again and set it in new buffer, and that is not the assignment operator, but it puts it into a valid, well-defined state. So you have not just the assignment operator you can call, but also other assignment functions.
Well, I think that's bad. I think the only thing you should be able to do with a stream is to move another stream into it. Yeah. I think we should look at some of the other stuff that's going on, other news stuff. I think Microsoft made some announcements. Do you want to talk about those, Ben?
Yeah, there were a few. There are a few things. So the VS15 installer has some, or the new VS15 toolchain has some C++14 fixes and 17 features. The thing I found interesting about that was that I was not previously aware that, so VS15 I think is slightly confusingly named because it's the next IDE iteration, as I understand it, it's the next IDE iteration of Visual Studio. It's not Visual Studio 2015. It's VS15. And they can be made to use the same tool chains because you can update it independently of the IDE. But that was interesting. That was something I didn't know before. And the latest update contains a couple of nice things from my point of view. The aggregate NSDMI initialization is a nice fix. So proper initialization of non-static data members, which are aggregates. And the other thing that is nice that's coming down the pipe is optional. But according to STL on Reddit, they have no plan to make optional available in Visual Studio 2015. So
it's not quite.
If I want optional, I'll need to move my project forward again. So if I want a standards-based optional.
Yeah, I was going to say you can still use Boost optional. It's still there.
And yes, and it's good, and I do. But I'm looking forward to having a standards-based optional that is, usable across and becomes part of our common language, I suppose.
So one of the things that they announced was support for ranges, range v3.
Yes, and that's pretty exciting. I'm in games industry, so it's pretty much C++ games programming means pretty much Visual Studio, 90+%. So modern C++ adoption in the games industry has largely been. I mean, it's starting to get going now, I think, across the board.
Let me ask a question about that. I don't want to derail you, but why is that? Is that because people are writing for Xbox and you use Visual Studio for that? What about other?
Well, it's true, actually. I think it's a historical thing that historically we wrote games for PCs, and then even when we wrote games for consoles, it was typically a PC-based dev environment.
You're right. In fact, it on the console, obviously.
Right. But I spoke a little bit. I was painting a broad strokes a little bit because you're right. On some of the consoles, historically there have been other compilers.
Okay.
But I think it's true to say that for most C++ game industry developers, they're used to working in the Visual Studio IDE.
Okay. It was just a question I had, and I think you answered it. So I didn't mean to derail you. Go ahead.
No. What was it? So range. So I was going to say that I think modern C++ in the game industry is now gaining a foothold because especially because a lot of things that have come along with 11 and 14 and subsequently have been really good in terms of giving zero-cost abstractions, and things like move semantics also it's not a zero-cost abstraction from a point of cognition, but but game developers are really hyper-focused on performance, so move semantics are cool.
Yeah.
So anyway, that was a roundabout way of saying that. We'll get into the point that I think ranges are really good. I've been following ranges for a while. Last year, I wrote a series of blog posts where I sort of took them for a test drive and tried to implement some stuff. I'm a big fan of the kind of declarative style that ranges kind of brings to the table, while keeping all the performance that we like in terms of just iterating sequences once and all that kind of thing. So I think now that ranges is finally available in Visual Studio or on the Microsoft toolchain, I hope that we'll see some uptake, and I'm excited to see what can be done with ranges.
And my understanding is that I thought ranges was based on the concepts, but I guess I'm understanding. I mean, STL was asked this question, and he said, well, actually, concepts are emulated, and they have some headers that emulate the concepts, and that ranges actually is using that. Is that how that works? It's not true concepts light that's been implemented.
Right. I mean, I don't know the ins and outs of the implementation, but my gut feeling is that so Eric wrote concepts for ranges originally. My gut feeling is that any kind of concepts library in current C++ relies heavily on expression sphenae, and that's something that's been known lacking in Microsoft's toolchain, and they have been working on that, and they've got enough support in that now for certain cases, certainly in the STL, and now it seems in ranges. So,
wow.
Good deal.
Yeah. I know that's one of the things that people who want to use HANA or something like that, this is a problem.
Yeah.
Visual Studio is just tantalizingly close, right? It's not quite there yet. So let's see, what else is going on? There was a blog post called "Using the Standard Library." Did you get a chance to look at that? I was kind of.
I did. Were you going to say something, Jonathan?
No, go ahead.
No, go.
Oh, well, so this was a blog post that gained some flack on Reddit because the basic gist of the blog post was here I had a problem, and myself and a colleague figured out this solution, and then I went and I looked at the standard library and I tried a different solution that was kind of off the shelf from the STL algorithms, and when I compared them, the STL was clearly better. Well, the actual solution presented in the blog post was an n-squared algorithm, where the STL was an n log n algorithm. I mean, so hardly surprising that STL performed better. But I think the takeaway from this is, for me, I've long been a proponent of knowledge of the STL algorithms in particular. In the games industry, the STLs historically had a bad rap because of ropey implementations back through the 90s, and because of, in particular, the containers not being good fits, in particular their allocation strategies not being good fits for the kind of problems that games address in many cases. But people tend to, when they think of the STL, think of the containers, and I would much rather they think of the algorithms. And maybe I'm speaking out of turn here, but I think Alex Stepanov would also rather associate the STL with the algorithms.
I think you're on solid footing there.
So, I mean, the takeaway for me is, the knowledge of the STL algorithms is really useful. I find it useful every day. And there are always going to be cases where you need that extremely optimized performance, and you need to do your own thing. But STL, gives us good performance off the shelf. And this blog post, that message unfortunately was obscured because of the fact that it was an n-squared algorithm against an n log n algorithm, which was chastised a bit.
Yeah.
But yeah, I think, as programmers, we solve problems, and it's often easier to solve a problem yourself than to realize that somebody else has solved it.
Right.
And use their solution.
Well, and sometimes, and Sean has a great talk on this where he gave a particular example. I don't want to go into the whole thing, but if you recall, it was the situation where we have a user interface where there's a number of items, and you want to be able to select an arbitrary pattern of them and take all the selected ones and drag it away and place it in a place, right? And that looks like that's just amazingly complicated, and it turns out, no, if you actually understand the STL algorithms, it's not a single algorithm, but what it is you apply two different ones, and it's very straightforward. And in fact, it's surprisingly straightforward. It's really amazing, and I think this is something that happens. I think one of the really interesting algorithms is rotate, which the first time you read it, you have to read it 2 or 3 times to say, what the heck is it talking about? And then once you kind of figure it out, it's like, why would I ever use that? And it turns out, no, you're going to use that a lot, but never by itself. It's part of a larger set of steps.
Yes. It's a compositioning algorithm. You only compose it with others to do the stuff you want.
Right. So
so there are lots of. I ran into a case the other day. I think what I want to do is kind of have an algorithms cookbook for sort of things like, I want to do this. Which algorithm should I use? Because there's not, obviously there's not a one-to-one mapping. You don't always. It's not as obvious as I want to sort. Sometimes it's things like I want to check if the example I ran across the other day was I want to check if a string is a prefix of another string. Now anyone who knows the algorithms knows that's mismatch. And yet there are tons of raw loops I see in code, as Sean would have it, that re-implement things like that.
Right. So this cookbook, are you going to self-publish this, or do you want me to give somebody at O'Reilly or something?
No, I don't think it'll be a book necessarily.
Okay.
Some kind of reference.
Well, we'll talk to his name is escaping me, which is embarrassing, but CPV reference. I think his name is I want to say Neil. I can't think of his name right now. But we'll talk to him, and if you want to do common use cases for algorithms,
might be a good addition.
Yeah, I think he'd be all over that. Yeah. Well,
I was going to say, I know that from last year's CppCon, after Sean's C++ seasoning talk, that sort of lit the fire under several people, I think, in terms of becoming interested in algorithms, myself included. Last year, there was a talk at CppCon by Michael Van Loon, I think, from F5, and Rachel, also from F5, and they were talking about algorithms. And I think Michael said he was working on some kind of publication, so I need to get back in contact with him.
Okay. Well, we're kind of running out of our time here. I want to thank both of you guys for being on here. Thank you, Ben, for sharing your ideas about algorithms and type theory, and thank you, Jonathan, for putting up with me screaming that you're wrong, you're wrong, you're wrong.
I'm used to that by now.
As long as it's constructive.
Yes. Well, I hope it is. I hope it is. It's important to get these things out there and discussed, and let's get some talk, because whatever we decide, let's not decide it all as a bunch of individuals in our own code bases. Let's try to get the community to talk about it. And, speaking of which, I invite everybody to join us in September to do that in Bellevue. Anyway, so we're winding up. So I'm gonna say to everybody, safe coding.
All right. Thank you, and safe coding.
Thank you. Safe coding.
All right. See everybody next week. Bye.